All right, we're going to work through what I call a rate in, rate out problem. And in AP Calculus lingo, this is the calculus processing problem. I'm sorry, the gravel processing problem. I call it a rate in, rate out problem because we're dealing with two rates. Here, we've got a gravel processing plant, and the gravel is arriving at a rate of this. So this is the rate in here. This is the time period that it's happening on. This is the initial value, 500 tons, and then this 100 tons per hour is the rate out. So the first question, part A, says, tell me what is G prime of 5? Well, remember that G is already the rate. So G prime is going to be a rate of a rate. So whatever value we get is going to be the rate at which the rate is changing. So let's go ahead to our y equals screen. And I've already typed it in here, 90 plus 45 cosine of x squared over 18. Make sure you're in radian mode. We don't do anything in calculus in degree mode. And notice that I have my derivative set up here to take the derivative of the function in y1 and make sure it happens for all x values. And then I made sure to not have this equals sign clicked, but to have this equals sign clicked, so I'm only going to see the graph of the derivative. And I'm doing a basic zoom 6 because I need to see where time equals 5, which will definitely show up when I'm looking on a standard window. You see this rate of a rate graphing, and even though it looks like when time is 5, the rate is out of the window, that's okay. I can still evaluate as long as the x value is within the window, I can still evaluate. So I'm going to do second calc and value. And I'm choosing 5, and I get negative 24.587 or 0.588. So negative 24.587 or negative 24.588. Either one is acceptable. And because this is a rate of a rate, what we have here is that this is the rate at which the rate of arrival is decreasing at time equals 5, and it's time equals 5 hours, and the units are tons per hour squared. Tons per hour squared. It's an acceleration. All right, part B of this problem states, find the total amount of unprocessed gravel that arrives during the hours of operation on this weekday. The total amount of unprocessed gravel that arrives. That is just going to be the integral. They're asking us to integrate on 0 to 8, the hours of the workday, our G function. So we're integrating G on the hours of 0 to 8. So in my TI, I'm going to go back to my home screen, and I'm going to choose to work with the integral here. I'm going to choose alpha F2, and choice 4 is the integral. I'm integrating from 0 to 8. And since I already have the graph in y1, I'm going to choose y1. So I hit vars, yvars, function, and y1. It's right there. I need y1 of x. And then I'm going to integrate with respect to x, so dx. And look what's going to happen. 825.551 tons. 825.551 tons of gravel arrived at the lot or at the plant during the 8-hour period that we're given. All right, now part C says, is the amount of unprocessed gravel increasing or decreasing at 5? So what they're asking us for is G of 5, which is the rate that the gravel is incoming, minus 100, which is the rate that the gravel is outgoing. So the question is this positive or negative? Because they want to know if the amount of gravel is increasing or decreasing. So if the rate, net rate, is positive, there's more gravel coming in than going out, but if the net rate is negative, there's more gravel leaving. So let's go ahead back to our graph screen, and I'm going to highlight the first graph and not the second, because I actually want to see the G graph, which is the rate. So I need that at 5, so I can do my standard window still. And I'll go ahead and graph it. And as I think about it, I'm not actually going to see it because this graph is pushed up by 90, that's the midline, and it has an amplitude of 45. So perhaps just to see it, I should take a look at the X values from, say, 40 to 140. I didn't mean the X values, haha. I meant the Y values from 40 to 140. So let me go back on my X values and do normal, and then I want 40 to 140 for the Y values. And let's hit the graph now. Now I'm seeing that cosine graph. And I really just want to evaluate this at time equals 5. I don't really want that horizontal line in there. That must be in there from another problem. So let's get rid of that and go back to the graph of just the rate in. Okay, so I'm going to evaluate this. Second trace value is going to be 5. So at time equals 5, my rate in is 98.141. 98.141 is rate in. Your rate out is 100. That expression is less than 0. And so the amount of unprocessed gravel at the plant is decreasing at time equals 5 hours. All right, the final part of the problem asks us to talk about the maximum amount of unprocessed gravel. So to get the maximum amount, I need to have the derivative equal to 0. Well, in this case, the derivative is the G, which is the rate in, minus the 100 is the rate out. So I need G of t minus 100 equals 0. Well, that's the same thing as G of t equaling 100. Okay, and they only want us to care about the time period 0 to 8. So we're going to go to our graph. What we're going to do here is we're going to actually put in a horizontal line of y equals 100. Okay, then I'm going to change my window for the x values to just 0 to 8 because I want to know just on that time frame when these two graphs are equal to each other. So this is my rate in graph. And then I'll have my rate out graph right here. So I have one critical point to look at, plus of course I need to look at the two endpoints, 0 and 8. So let me find where this intersection point is. Second calc, choice 5 is intersect. First graph, second graph, guess. So I hit enter 3 times. And at 4.923, I have a critical point. 4.923. I also need to compare at 0 and at 8. So of course I'm doing my table of values. I have my time here, and I have my tons of gravel here. The nice thing is they gave me at the outset, they told me I had 500 tons of gravel. So I have 500 right here. For this piece, I need to take that original 500 and I need to integrate my rate in from 0 to 4.923, and I'm just going to call that G right here, minus my rate out on the same interval. Okay, so I'll do that in my calculator in a few minutes. And then here for 8, I've got 500 plus the integral from 0 to 8 of G minus 100 dt. So let's see what the easiest way to do this. I'm thinking if I put G of t minus 100 in my graph screen on my TI, let's try that. I go over here to my graph screen and I have G of t, let's subtract out 100. That is going to be my integrand. And I don't need to see the graph. I just needed that equation in the y1. Now if I go to my home screen, what I want to do is take my original 500 and add to it. I'm going to go to alpha, integrate. Choice 4 is integrate. I'm integrating from 0 to 4.923. and I want to integrate y1. So remember, I go to vars, yvars, function, choose y1, make sure we say of x, and then integrate with respect to x and hit enter. This is going to give us the amount of unprocessed gravel at time equals 4.923. That is 635, let me write this in here, 635.376. Okay, so compared to 500, this one's already winning. Okay, this one's not going to be it because 635 is better than 500 or bigger than 500. But now I need to check at 8. So you know what I'm going to do? I'm going to hit second enter, and it enters that whole thing I already had up top, and all I have to do now is change my upper limit of integration to an 8. Delete, 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 and just put in a nice 8 there. Okay, looks good. Hit enter. And only 525.551. 525.551. Make sure you're writing in all these values because you do have to show that the value of 635 is bigger than the other two. This is not the correct answer. This is 635.376. Don't forget to write tons in because you'll need the units. This table serves as the justification for your answer.